Myself, Megha Rathod. I am teaching maths in LPSAVANI VIDHYABHAVAN. Today we start chapter number 2, Polynomials. First, we discuss about the important notes. First is a constant. A symbol having a fixed numerical value is called a constant. Second, variable. A symbol which has different numerical values is known as variable. Example, 5x minus y plus 3. Here you can see 5, minus 1 and 3 are constant and x and y are variables. Variables means A, B, C, D, P, Q, R, S, T, any you can write, and constant means numbers. Next, algebraic expression. A collection of constant and variables connected by some or all the operations. Operations means plus, minus, multiplication and division is called an algebraic expression. Example, 4 by 3 x square plus 4xy plus 2x minus 3y plus 5 is an algebraic expression. Here 4 by 3 x square, 4xy, 2x, minus 3y and 5 are the terms. 4 by 3, 4, 2, minus 3, 5 are constants. X and y are variables. In term 4 by 3 x square, 4 by 3 is the coefficient of x square. Now next, polynomial. An algebraic expression in the form of a0 plus a1x plus a2x square plus plus a raised to n minus 1 x raised to n minus 1 plus a raised to n into x raised to n, where a0, a1, a2 an are constants and the coefficient of x0, x1, x square x raised to n, and n is called the degree of the polynomial. Here n is the degree of the polynomial. Now we have to learn how many types of the polynomials. There are two types of the polynomials, main according to term and according to degree. First of all, we discuss about the according to the term. First, monomial. A polynomial having one term is called a monomial. Example, 4x square. Here only one term, 4x square. Binomial. A polynomial having two terms is called a binomial. Example, 4x square plus 3. Here two terms you can see, 4x square and 3 is the two terms. So this is called a binomial. Trinomial. A polynomial having three terms is called a trinomial. Example, 2x cube plus 3x square plus 4. Multinomial. A polynomial having more than three terms is called a multinomial. Example, 6x5 minus 10x cube plus 4x square plus 2x minus 12. Fifth one is a zero polynomial. Number itself is known as zero polynomial. Example number 5, minus 10, etc. Here variable is not present. Now, according to the degree. First, constant polynomial. A polynomial of degree 0 is called constant polynomial. Here 3, minus 4, etc. are the constant polynomials. Second, linear polynomial. A polynomial of degree 1 is called a linear polynomial. Here example, 2x plus 5, 2y minus 8, etc. are the linear polynomials. Third number, quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. Example, x square plus 6x plus 3, zx square plus xy plus y, etc. are the quadratic polynomial. Fourth, cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. Example number, x cube plus 9x square plus 27x plus 27. This is the cubic polynomial because your maximum degree is 3. Now fifth one, biquadratic polynomial. A polynomial of degree 4 is called a biquadratic polynomial. Example number, x raised to 4 minus 3x cube plus 2x square minus 4x plus 3. And the standard form of the biquadratic polynomial is ax raised to 4 plus bx cube plus cx square plus dx plus e. These are the biquadratic polynomials. 6th number, zero polynomial. A polynomial 0 is called a zero polynomial. The degree of zero polynomial is not defined because 0 is equal to 0x raised to 0 is equal to 0x into 0x square. We can write. Now, we discuss some useful algebraic identities. Here 10 identities you have to learn properly. First is x plus y whole square is equal to x square plus y square plus 2xy. X minus y whole square is equal to x square plus y square minus 2xy. Third is x square minus y square is equal to x plus y and x minus y. Fourth one is equal to x plus a in bracket and second bracket x plus b is equal to x square plus in bracket a plus b into x plus y square. Fifth one is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Sixth number, x plus y whole cube is equal to x cube plus y cube plus 3xy into bracket x plus y. We have to write again x cube plus y cube plus 3x square plus 3xy square also. Seventh one, x minus y whole cube is equal to x cube minus y cube minus 3xy in bracket x minus y or x cube minus y cube minus 3x square y plus 3xy square. Eighth one, x cube plus y cube is equal to x into y one bracket, second bracket x square plus y square minus xy. Ninth one, x cube minus y cube is equal to x minus 1 in one bracket, second bracket x square plus y square plus xy. Tenth one, x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z in one bracket, second bracket x square plus y square plus z square minus xy minus yz minus zx. If in this identity x plus y plus z is equal to 0, then we can write x cube plus y cube plus z cube is equal to 3xyz. All identity you have to write 10 times in your fair book. Now we have to start exercise 2.1. Question number 1. Which of the following expressions are polynomials in one variable and which are not? State reason for your answer. First number, 4x square minus 3x plus 7. Here, the exponent of variable x are whole numbers. This is a polynomial in one variable. Second number, y square plus root 2. Here, the exponents of variable y are whole number. This is a polynomial in one variable. Third number, 3 into root t plus t into root 2. Here the exponent is 1/2 is not a whole number. So this is not a polynomial. In polynomial always degree are in whole numbers. Fourth one, y plus 2 upon y. Here you can see y plus 2y raised to minus 1. So the exponent is minus 1. Is not a whole number. So this is not a polynomial. Fifth one, x raised to 10 plus y raised to 3 plus t raised to 50. Here the exponent of each variable is a whole number. So this is the polynomial. In x, y and t, it means in the 3 variables. This polynomial is in 3 variables. Now question number 2. Write the coefficient of x square in each of the following. First, 2 plus x square plus x. Here second term is a x square. So we can see the coefficient of x square is 1. Second number, 2 minus x square plus x cube. The coefficient of x square is minus 1. Third number, pi by 2 x square plus x. The first term is pi by 2 x square. The coefficient of x square is pi by 2. Fourth one, root 2 into x minus 1. Since root 2x minus 1 is equal to 0x square plus root 2x minus 1. So the coefficient of x square is 0 because here the term x square is not present. Now we start exercise 2.2. Question number 1. Find the value of the polynomial 5x minus 4x square plus 3 at x is equal to 0, x is equal to minus 1 and third is x is equal to 2. First, x is equal to 0. Let px is equal to 5x minus 4x square plus 3. Then p0 is equal to 5 into 0 minus 4 into 0 square plus 3 is equal to 0 minus 0 plus 3 is equal to 3. The value of 5x minus 4x square plus 3 at x is equal to 0 is 3. Second number, x is equal to minus 1. Let px is equal to 5x minus 4x square plus 3. P minus 1 is equal to 5 into minus 1 minus 4 into minus 1 square plus 3. Here, 5 into minus 1 means minus 5. Minus 4 minus 1 square means plus 1. So, minus 4 plus 3 is equal to minus 9 plus 3 is equal to minus 6. The value of 5x minus 4x square plus 3 at x is equal to minus 1 is minus 6. Third one, x is equal to 2. Let px is equal to 5x minus 4x square plus 3. Then p2 is equal to 5 into 2 minus 4 into 2 square plus 3. 5 into 2 means 5 2s are 10 minus 4 into 2 square. 2 square means 4. So 4 4s are 16. So minus 16 plus 3 is equal to 13 minus 16 is equal to minus 3. So the value of 5x minus 4x square plus 3 at x is equal to 2 is minus 3. Question number 2. Find p0, p1 and p2 for each of the following polynomials. First, py is equal to y square minus y plus 1. So first y is equal to 0. So p0 is equal to 0 square minus 0 plus 1. So 0 minus 0 plus 1 is equal to 1. Then y is equal to 1. P1 is equal to 1 square minus 1 plus 1. 1 minus 1 plus 1 is equal to 1. Y is equal to 2. P2 is equal to 2 square minus 2 plus 1. 2 square means 4 minus 2 plus 1 is equal to 3. Now question number 3. Give one example each of the binomial of degree 35 and of monomial of degree 100. First number. A binomial of degree 35 can be 4x raised to 35 minus 5. Here two terms, so this is a binomial. Second number. A monomial of degree 100 can be root 6 y raised to 11. It is a one term, so this is monomial. You can write any example of binomial and monomial. Now question number 4. Write the degree of each of the following polynomials. First, 5x cube plus 4x square plus 7x. In this polynomial, the highest power of variable x is 3. So, the degree of given polynomial is 3. Second number, 4 minus y square. In this polynomial, the highest power of variable y is 2. So, the degree of the given polynomial is 2. Third number, 5t minus root 7. In this polynomial, the highest power of variable t is 1. So, the degree of given polynomial is 1. Fourth one, 3. The given polynomial is a constant polynomial. So, the degree of the polynomial is 0. The constant polynomial, in constant polynomial, the degree is 0. Question number 5. Classify the following as linear, quadratic and cubic polynomial. First, x square plus x. The degree of this polynomial is 2. So, it is a quadratic polynomial. Second number, x minus x cube. The degree of this polynomial is 3. So, it is a cubic polynomial. Third number, y plus y square plus 4. The degree of this polynomial is 2. So, it is a quadratic polynomial. Fourth, 1 plus x. The degree of this polynomial is 1. So, it is a linear polynomial. 3t. The degree of this polynomial is 1. So, it is a linear polynomial. Sixth one, r square. The degree of this polynomial is 2. So, it is a quadratic polynomial. Seventh one, 7x cube. The degree of this polynomial is 3. So, it is a cubic polynomial. Now, we complete our exercise. Now, second number pt is equal to 2 plus t plus 2t square minus t cube. So t is equal to 0. P0 is equal to 2 plus 0 plus 2 into 0 square minus 0 cube. is equal to 2 plus 0 minus 0 is equal to 2. T is equal to 1. P1 is equal to 2 plus 1 plus 2 into 1 square minus 1 cube. So 2 plus 1 plus 2 minus 1 is equal to 4. T2 is equal to P2 is equal to 2 plus 2 into 2 square minus 2 cube. Here 2 plus 2 plus 2 into 2 square means 2 to the 4, 4 to the 8, so plus 8. And then 2 cube means 2 to the 4 to the 8, minus 8. Plus 8 minus 8 cut. So remaining is equal to 4. Third number. Px is equal to x cube. So x is equal to 0. So px is equal to 0 cube is equal to 0. X is equal to 1. So p1 is equal to 1 cube is equal to 1. And x is equal to 2. Then p2 is equal to 2 cube is equal to 8. Fourth one. Px is equal to x minus 1 into x plus 1 is equal to x square minus 1. So x is equal to 0. So p0 is equal to 0 square minus 1 is equal to minus 1. X is equal to 1. Then p1 is equal to 1 square minus 1 is equal to 1 minus 1 is equal to 0. X is equal to 2. Then p2 is equal to 2 square minus 1. 2 square means 4. 4 minus 1 is equal to 3. Now, question number 3. Verify whether the following are zeros of polynomial. Indicate against them. First, px is equal to 3x plus 1. Here give the value of x is equal to minus 1 by 3. So, p into bracket minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1. 3 cut is equal to minus 1 plus 1 is equal to 0. So, x is equal to minus 1 by 3 is 0 of the given polynomial because we get the value p minus 3 is equal to 0. Now number 2. Px is equal to 5x minus pi. X is equal to 4 by 5. P 4 by 5 is equal to 5 multiplied by 4 by 5 minus pi is equal to 4 minus pi is not equal to 0. So, x is equal to 4 by 5 is not zeros of the given px because here p 4 by 5 is not equal to 0. Third number. Px is equal to x square minus 1 where x is equal to 1 and minus 1. First, x is equal to 1. So, p1 is equal to 1 square minus 1 is equal to 1 minus 1 is equal to 0. X is equal to minus 1. Then p minus 1 is equal to minus 1 square minus 1 is equal to 1 minus 1 is equal to 0. Both x is equal to 1 and minus 1 are zeros of the given px. Fourth one. Px is equal to x plus 1 and x minus 2 where x is equal to minus 1 and 2. First, x is equal to minus 1. Then p minus 1 is equal to minus 1 plus 1 minus 1 minus 3. Minus 1 plus 1 cut 0 into minus 3 is equal to 0. X is equal to 2. Then P2 is equal to 2 plus 1 into second bracket 2 minus 2. So 3 into 0 is equal to 0. Both x is equal to minus 1 and 2 are zeros of the given Px. Fifth one. Px is equal to x square. X is equal to 0. Then P0 is equal to 0 square is equal to 0. The x is equal to 0 is 0 of the given Px. Sixth one. Px is equal to Lx plus m where x is equal to minus m by L. So P minus m by L is equal to L into minus m by L plus m is equal to LL cut. So minus m plus m is equal to 0. So x is equal to minus m by L is zeros of the given Px. Because here P into minus m upon L is equal to 0 we can get. Number 7. Px is equal to 3x square minus 1. X is equal to minus 1 upon root 3 and 2 upon root 3. First number. X is equal to minus 1 upon root 3. P into minus 1 upon root 3 is equal to 3 into minus 1 upon root 3 whole square minus 1 is equal to 3 multiplied by 1 upon 3 because here minus 1 upon root 3 square is equal to 1 upon 3 minus 1. 3 cut remaining 1 minus 1 is equal to 0. X is equal to 2 upon root 3 where P into 2 upon root 3 is equal to 3 into 2 upon root 3 square minus 1 is equal to 3 multiplied by 4 by 3 minus 1 is equal to 4 minus 3 is equal to 3. So 3 is not equal to 0. So x is equal to minus 1 upon root 3 is zeros of the given px, but x is equal to 2 upon root 3 is not zeros of the given px. 8 number, px is equal to 2x plus 3 where x is equal to 1 upon 2. So p 1 upon 2 is equal to 2 multiplied by 1 upon 2 plus 1 is equal to 1 plus 1 is equal to 2. 2 is not equal to 0. So x is equal to 1/2 is not 0 of the given px. Now question number 4. Find the 0 of polynomial in each of the following cases. First, px is equal to x plus 5. And when we find the 0, we have to write px is equal to 0. So x plus 5 is equal to 0. The x is equal to minus 5. The x minus 5 is zeros of the given px. Second number, px is equal to x minus 5. So px is equal to 0. X minus 5 is equal to 0. The x is equal to 5. So x is equal to 5 is the zeros of the given px. Third number, px is equal to 2x plus 5. Then px is equal to 0. So 2x plus 5 is equal to 0. So 2x is equal to minus 5. The x is equal to minus 5 by 2. So x is equal to minus 5 by 2 is zeros of the given px. Fourth, px is equal to 3x minus 2. Then px is equal to 0. 3x minus 2 is equal to 0. 3x is equal to 2. So x is equal to 2 by 3. Here 3 in multiplication. So in opposite side of equal to, we can write in denominator. So 2 by 3. X is equal to 2 by 3 is zeros of the given px. Fifth number, px is equal to 3x. So px is equal to 0. 3x is equal to 0. So we can write x is equal to 0. Because if we write 0 upon 3, but value is 0. So x is equal to 0. So x is equal to 0 is zeros of the given px. Sixth one, px is equal to ax. A is not equal to 0. So px is equal to 0. X is equal to 0. So x is equal to 0. So x is equal to 0 is zeros of the given px. Seventh one, px is equal to cx plus d, where c is not equal to 0, cd are real numbers. So px is equal to 0, cx plus d is equal to 0, cx is equal to minus d. So x is equal to minus d by c. So x is equal to minus d by c is zeros of the given px. Here we completed exercise 2.2. So everyone, write all the sums in your fair book carefully.